Hello students, in this particular video we are going to discuss force on a moving charge in a magnetic field. So when a charged particle moves in a magnetic field experiences that particular charge experiences force in magnetic field, and such forces are not for static charge. So we are writing here the electric charges moving in a magnetic field experiences a force, while or on the other hand we can say for a static charge there are no such force, while there is no such force on a static charge. So the concept is when electric charge moves in a magnetic field they experience some force. Okay, so now next to that, how do we define the magnitude of force? For that, let us assume this is y axis, this is z axis, and let's say this is x axis, and the charge is moving with the velocity of v, making an angle of maybe theta with this particular y axis. Then we can say this velocity will have two component, one is v cos theta along y axis and one will be v sin theta. So this is the velocity of the charged particle. So the magnitude of force is given by the magnetic force which is acting on this particular charge q. That force is proportional to magnetic field B, and if B is pointing, let's say, in this particular direction only, this is the direction of magnetic field, so the force on this particular charge will be proportional to magnitude of magnetic field. It will also be proportional to amount of charge, and it will be proportional to B sin theta. Okay, so if we combine all together, we can say force is proportional to q vb sin theta. So if we remove the proportionality sign, it will become q vb sin theta, proportionality with some constant k, and let us assume that k value is equal to 1. So now force will be equal to q vb sin theta. Acha, we know that when sin theta is coming, it is basically cross product of v and b. So we can say in vector form, for force is q into v cross b. This is cross product of velocity vector and magnetic field vector. So the direction of force is going to be perpendicular to both velocity vector as well as magnetic field vector. As we know, when we take the cross product of two vector, so the resulting quantity will be perpendicular to both v vector and b vector. So force will be perpendicular to both v and b, and from this equation, if theta is equal to 0 degree, force will be equal to 0 because sin 0 will be 0. If theta is equal to 90 degree, qvb So it is maximum QVB, sin 90 is 1, and when theta is 180 degree, again force will be 0 as sin 180 degree is 0. And the direction of force, we know how to find the direction of cross product. We can use Fleming left hand rule. Fleming left hand rule is used to find the direction of force on a moving charge in magnetic field. So the point is, how do we apply Fleming left hand rule? So in our left hand, forefinger is the finger just adjacent to thumb in the left hand. Forefinger points in the direction of magnetic field. Then central finger points in the direction of current. Then thumb will point in the direction of force. Okay. So I stands for current, B stands for magnetic field, and F stands for force. And we have to stretch all these three fingers at 90 degree with respect to each other, mutually perpendicular direction. Okay. So we are writing here forefinger, it will point in the direction of magnetic field. B, central finger, in the direction of current or the direction in which charge is moving. Okay. Its direction of current or charge movement, and then thumb will point in the direction of or gives the direction of force. So this completes this particular explanation. I hope it is clear to all of you. Thank you.